Welcome to the second lecture of the Blockchain Business Management and Planning module. The topic of this lecture is Fundamentals of Business Management 1. To understand the content of this lecture, we recommend that you have previously watched the lectures of Module 1, Introduction to Blockchain Methodology, and Module 3, Fundamentals of Blockchain and Distributed Ledger Technology. However, even without prior knowledge from the previous modules, you should be able to understand the main content of this lecture. The learning material is designed to provide you with important future skills, ALS 2020, to gain the ability to effectively manage or develop blockchain services and processes. After introducing the learning objectives of this module, we will give an insight into stakeholder analysis to identify the participants in the blockchain network. Afterwards, we will show methods for mapping products and services in order to find suitable application areas for the technology. Following this, various decision models will be presented to help weigh up the feasibility of the application of the technology. Finally, the lecture ends with a short conclusion. This slide shows an overview of the knowledge, skills, responsibilities, and autonomies you will acquire in this lecture. In this module, different processes and business management methods are presented to show which criteria are important for a purposeful use of the technology. It should be noted that in general, the process and the problem should always be examined first without considering blockchain as a set solution for the problem. Furthermore, use cases should not be constructed afterwards that only allow blockchain as a possible solution. However, since this is a blockchain-specific module, we will always try to establish a blockchain reference. Two questions need to be answered. First, is blockchain the appropriate technology for the realization of the specific use case? And second, if so, what type of blockchain is best suited for the realization? The first question we ask ourselves is, who are my company's stakeholders? The stakeholder concept dates back to 1963 and was developed at Stanford Research Institute, SRI, to make managers aware of stakeholders other than the shareholder, owner. Stakeholders are persons, groups, or organizations that have a relationship with the company and have expectations towards the company. A distinction is made in the stakeholder analysis between internal and external stakeholders, as these different groups have very different demands and expectations of a company. Both stakeholder groups, internal and external, must be included in the corporate strategy. In addition, management should be clear about what corporate strategy towards these stakeholders should be, whether and when it has to be about action or reaction. With regards to projects and the examination of whether an internal company idea can be a worthwhile project for a blockchain solution, it is therefore important to identify all relevant stakeholders and assess what influence these stakeholders could have on the company and the project. In principle, the following questions can be used to approach the classification of stakeholders. Who are the current and potential stakeholders, external and internal? What influence does each stakeholder have on the company and vice versa? How important is each stakeholder to the success of the company? What are the factors and the variables that have an impact on the company? How are these variables and their influence on the company or other stakeholders measured? Can these variables be measured at all? Now that the stakeholders have been identified, it is good to make an assessment in terms of influence, power, conflict potential, and, if applicable, worldview, attitudes, wishes, hopes, and so on. It is advisable to first position the identified stakeholders on one axis according to their influence in order to apply the other axis dimension in a second step. In summary, the stakeholders in the upper right quadrant are significant. Identified stakeholders who are assessed as important could be potential nodes of the blockchain network in an emerging blockchain solution, and thus, depending on the consensus and protocol, actively contribute to the validation of the individual transactions to be carried out. While the stakeholder mapping gives an overview of potential blockchain participants, the products and services mapping can show what the products of your organization are and what processes and activities lie behind them, which can be optimized using blockchain technology. To this end, you can fill in a story map, brainstorm all the products and services your organization offers, and place the result in the header of the mapping map. Identify processes or activities and value propositions and place the information in the appropriate columns. Value proposition revolves around the benefits that are created towards the customer or towards suppliers and other stakeholders. The processes and activities can then be derived relatively easily from the value proposition. What does a company have to do in the background to fulfill the value proposition? It is important to consider how deep one wants to go into process levels. We recommend to do a high-level process overview. This value proposition can also be seen as a statement of intent, because it shows what a company stands for. An example would be a hotel room. The product and service is the room. The service promised to the customer is high standards and a pleasant stay. The underlying process is, for example, room cleaning. In the final step, move the elements that are data-driven to the footer. In terms of blockchain technology, the story map can show which of the activities can be carried out as transactions or with the help of a smart contract, for example. Values, on the other hand, could be used as coins or tokens in the future business model. Value stream mapping, VSM, is a method from lean management. Here, processes are systematically recorded and can then be redesigned. The method is intended to help optimize internal processes and to be able to react more quickly to market and customer requirements. VSM is a process of mapping the primary material and information flows in converting raw material to finished product, or creating a service of value that a customer is willing to pay for. In value stream mapping, all elements of the process are visualized and linked chronologically. With the use of a decision path, you can clarify whether, and if so, which type of blockchain you should apply to your use case. As already shown in Lecture 4.1, there are various decision models for the application of blockchain technologies. We will now present a few well-known models that can help to determine whether the blockchain technology makes sense for a selected use case. The Graham 2018 decision model asks whether data should be stored and updated by multiple parties in the planned use case, and whether a common basis of trust is required for this. These questions serve to distinguish between a centralized and a decentralized database. In order to further delineate the blockchain relevance, additional questions are asked about problems with the central trust authority and the dependency between the parties involved in a transaction. If all questions can be answered with yes, the use case is suitable for the use of a blockchain according to Graham's model. It should be emphasized that permissioned blockchains are not considered in Graham's models. He builds this model primarily for the decision for or against a permissionless blockchain. A short explanation. Permissionless blockchains, also known as trustless or public blockchains, are open networks available to everyone to participate in the consensus process that blockchains use to validate transactions and data. In contrast, permissioned blockchains, also known as private blockchains, are closed networks, in which previously designated parties, sometimes members of a consortium, interact and participate in consensus and data validation. They are partially decentralized in the sense of being distributed across known participants rather than unknown participants, as in permissionless blockchains. In the decision tree by Gervais and Vues, the permissioned blockchain was included. In this model, it's shown under which circumstances a certain scenario can be sensibly solved with blockchain technology, or whether alternative technologies, such as a central database, would be better suited. As with Graham's model, the first basic question is whether there is a need to store data and whether there are several known nodes with the right authorization writers, as well as a trusted third party, abbreviated here as TTP, which could act as a transaction intermediary. Each of these fundamental questions could lead to a decision against blockchain. The distinction between permissionless and permissioned blockchains is based on the question of whether all right authorized nodes in the network are known and trusted by all network participants. If all right authorized nodes are known, but not all are trustworthy, an additional subdivision is made between public permissioned blockchains and private permissioned blockchains. This subdivision has the consequence of whether all nodes in the network receive read access in order to verify all states of the blockchain, or whether there are only defined nodes with read permission, which can verify specific transactions for them. The Lewis decision model is intended to bring us back down to earth, and above all, to question the current blockchain hype. The questions are posed in a very self-deprecating way, and right at the beginning, he asks us to name a real problem in the business world. He considers the problem of different standards, which are based on the fact that all participants use different technologies to be outdated. If the answer is yes, the question follows whether this can be solved in a way other than via blockchain. If this is the case, then one of the conventional databases is recommended. With the subsequent question of whether the approach is digital identities and or blockchains are free, this model draws attention to the fact that digital identities with asymmetric key pairs, for example in the form of public and private keys, have been around for more than 20 years. Systems of this kind are cheap. Companies, on the other hand, have more costs when they generate their own. Startups, on the other hand, might have cost advantage. Conventional databases are better suited to handle this more familiar approach. Unless we're talking about blockchain for free or digital identities, this model approach questions whether a company should or could have sole overriding control. If the answer is yes, one is confronted with the question of how common right ledger can solve this business problem better than existing efficient systems. Unless one has a good answer, the model then points back to the use of a traditional database. If the question of control in an organization was answered with the negative, the model questions whether participants need to update or replace the system. If so, can participants adopt it? And do benefits justify the cost of adoption? Provided it can be assumed that participants do not mind the visibility of their data, then it could be a worthwhile use case. Further development of the business model should focus on privacy and scalability. However, if potential participants have objections to making their data transparent, then this model recommends reconsidering the use of traditional databases. Derived from the previous models, Urban has developed another decision model. Here, a distinction is also made between should and can criteria. Should criteria are those that should be fulfilled in order to be able to use blockchain as a meaningful technology at all. The fulfillment of optional criteria, on the other hand, highlights particularly suitable use cases, but does not completely rule out any idea in the event of non-fulfillment. In addition, a distinction is made between the three criteria groups of organizational structure, technology, and transaction data and rights system. The aim of the first two groups is to fundamentally examine whether blockchain should be used as a suitable technology. The third group focuses on the examination of configuration ideas in relation to data processing. The third group focuses on the examination of configuration ideas in relation to data processing and the role and rights, and identifies unfeasible combinations of requirements. Group 1. Organizational structure. The first group describes the organizational structure. That is, who are the potential participants? What kind of cooperation prevails in the ecosystem? And what is their transaction and trust relationship? The aim is to gain a holistic view of the business relationships in terms of exchange of transactions. Do more than two participants have to share data? Since blockchain functions as a network, and the manipulation security and the associated trust are only achieved through several local copies of the ledger, at least 3 participants are required. Should transactions be traceable and trustworthily secured? Traceable and trustworthy data storage is the core element of the blockchain, and at the same time the main advantage of this technology compared to other technological solutions, most of which can only map this with great difficulty, or not at all. Is there a central, always available trust center, short CTC, for example, a bank for finance? A central organization that bundles transactions or business processes in an ecosystem acts as a trust center through its role and is recognized by the other organizations. Are there conflicts about who forms the CTC or controls the data management? In particular, as the complexity of business network increases, high number of participants, it becomes more difficult to identify an organization that all participants trust, so that it can act as the CTC. Should the CTC be maintained? Does the CTC lead to inefficiencies such as longer process cycle times and additional costs? If there is a CTC, it usually has to be financed by the other network participants, for example through transaction fees, and leads to a bottleneck in processing speed, which has a negative effect on the scaling of the process in particular. Do the business rules change less than once a quarter? Smart contracts in the blockchain network validate and check each individual transaction before it is executed. The prerequisite for this is that all network participants agree on a version of the smart contract that must be accepted by them each time it is updated. The increased adaptation of the business logic thus leads to a higher effort in updating the smart contracts in the network. Group 2. Technology. The second cluster examines the technological requirements for the use case and whether these can be realized in principle with a blockchain. Due to the mechanisms of reaching consensus through smart contracts, the validation execution of a transaction involves a certain amount of effort. As things stand today, blockchain is not suitable for mass transactions, such as credit card payments, as the scaling is not yet designed for this. Should transactions be high performance, processing in the millisecond range? Due to the typical blockchain architecture of distributing and validating transactions requests in the network and calculating and distributing new blocks, processing takes a certain amount of time, which makes it unsuitable for mass transactions at present, for example credit card payments, which require many transactions in a very short period of time. Are consensus and verification required for all participants in the business process? A core element of blockchain technology is to create a common consensus, data state, across the entire network, as well as to enable participants to validate data states and transactions afterwards. Should the data be stored in a tamper-proof way? Another core element of blockchain technology is tamper-proof data storage. Once a transaction has been written in the network, it can only be changed by an offsetting entry, but not by changing the transaction itself. Are data backups required due to redundancy, for example, backup of data? Since each active network node maintains its own local copy of the blockchain, transaction history, Traditional data backup for redundancy could be dispensed with. Do interfaces increase complexity in the ecosystem or lead to information asymmetries? For the current data exchange, organizations usually operate a large number of different interfaces to different external partners, which on the one hand increases complexity, but at the same time leads to information asymmetries, as different partners may receive data updates at different times. Group 3. Transaction data and rights system. After the use case has already been tested for basic blockchain relevance in the first two clusters, a concrete differentiation of the individual configurations of the blockchain is made in cluster 3, which serve as a concrete result for the user. In particular, the requirements for the role and rights systems are highlighted based on the data access or releases. Is a blockchain network with a public and private part needed? If a public and private network part is needed within a use case, both blockchain networks can be merged as a hybrid blockchain. Are all participants with write permission known? If all network participants with write permission are known, a private permissioned blockchain network can be used. If unknown third parties are involved, public permissionless blockchain networks must be used. Should each participant be clearly identifiable as a real person or organization? The clear assignment of technical network node to a real person can only be ensured in permissioned blockchain networks. Is each participant allowed to validate the transactions, execute smart contracts? Typically, each network participant has identical rights within the public blockchain. In permissioned implementations, however, specific rights can be assigned per participant, which can also include the execution of smart contracts. Should external systems or data sources be integrated? Oracles form the interface between the blockchain network and other third-party systems. Via oracles, data from the blockchain can be passed on to the outside or retrieved from the data sources external to the network. Should read access only be possible from selected network participants? In the permissioned blockchain, each participant can be given specific rights, which also includes the right to read certain transaction data. For the purposeful investigation of a concrete use case, the blockchain decision model is presented as a one-page flowchart. First, criteria groups 1, organizational structure, and 2, technology, must be run through. Starting with start, the individual questions are to be answered in relation to the specific use case, where blockchain can already be excluded as a suitable technology for the application scenario. The 4 optional criteria, or bonus criteria, of the first two groups indicate particularly useful areas of application, but do not exclude any application. If the first two groups have been completed without the answer to one of the questions being no blockchain, group 3 is started from the end field. This group no longer excludes blockchain as a technology basis, but makes a recommendation as to which type of blockchain is most suitable for the concrete application scenario. The procedure for answering the individual questions is analogous to the first two groups. The use of the decision model requires that the user is familiar with both the organizational and the technical background of the use case and can access it accordingly. Primarily, the model is used to check a potential use case for relevance to the use of blockchain, but not to construct a potential use case or a potential area of use from the available criteria. It is also assumed that the user has an initial basic knowledge of blockchain so that an understanding of the content of the criteria is ensured. Conclusion. In conclusion to this lecture, we can say that the fear of missing a big innovation leap in blockchain leads some companies to build the technology into inappropriate use cases, or to adapt these use cases for the use of the technology. The methods presented here are intended to give an indication of the extent to which the use of blockchain technology offers real added value. Please question your own motivation and that of your team. Why do you believe in a blockchain solution? Which type of blockchain with which orientation is most likely to help you answer the core questions you have asked? Have the courage to reject the blockchain solution, even if no added value is apparent. Being a blockchain expert also means being able to say no to the use of blockchain.